showing images of professors from Harvard, Yale, Princeton, and Stanford. All the teachers were in the classroom, not the center of attention. The students were the center of attention, and they're case-based. And the first thing a professor says was, "Don't you know that research tells us that we should lecture?" Okay, so keep doing what you're doing and you'll get the same result. So I gave the secret away. I'm finished.
Nina, over to you. I guess.
Thank you so much, Jessica. A beautiful presentation, and I'm sure that a lot of people will take away from that. Do we have any questions for Jessica, Arijit, from any members?
We have a couple of comments which actually came. One, I think I'll be taking. What is a strong leader in your opinion?
That's a very good question. A very good friend of mine, the King of Hawaii, King Edmund K. Pocky Silva Jr. would say it's first knowing yourself. And that goes back to some of what Jenny was saying, is being centered and knowing yourself. But I have a lot of ideas on this, and it's hard to pick one that would be the most important beyond knowing yourself. But being aware that, I think to start with, that leadership is not the same thing as management, and leadership is inspiring a shared vision. And the first word is inspire. So, and you can't inspire if you don't care about what you're doing. So know yourself so that you care and have passion about what you're doing enough to inspire that shared vision, and then translating that shared vision, letting people participate according to their own passion. But I have a lot of ideas on that. I know we're short on time, so I won't share them all.
Thank you so much. And yeah, when you come from a heart-centered place, it definitely shows, as Jenny was saying, you know, when someone talks about something with complete passion because they believe in what they're talking about, or they've been there themselves, it definitely comes through. And you're very lucky, because a lot of people never find that. They never find their why. So to have found it and to be doing something about it, you know, I commend you on that. So thank you so much, Jessica. We have another speaker now we're going to introduce. And for those of you who don't know me, my name is Nina. I am the World Leader Summit London ambassador. So I'm speaking all the way from, not far from Buckingham Palace, actually. So I'm coming over to you today. I do a little wave at you when you've got 5 minutes left. So just to let you know that when your 15 minutes are ticking away, it's quite easy for time to go quickly. We try to keep to the time because we're trying to respect everyone. It's quite difficult over the last few days. We've had internet issues. We've had speakers not being able to find the presentation. So bear with us. If you're waiting, we will get around to you, and thank you for your patience. Remember to ping people in to come and watch us. We are live on Facebook. We are live on Twitter, and we've had 90 countries over the last few days. You know, we've been having so many countries coming from everywhere. And I think we've had over 120 speakers, probably a lot more than that. So there's been a lot of knowledge shared, and a lot of people have given us very positive feedbacks. If you are not following Arijit on his social media, please do. Please share the page on Facebook so other people can see and log into. And also show World Leader Summit some love by following us on LinkedIn and sharing our pages too. So without any further ado, I'm going to go to the next speaker, who is Sumant. Sumant, are you there?
Yeah, hi. Hi, Nina. Hi, Arijit.
I'm going to give you 50 minutes. Thank you.
Yeah, okay. So should I start my presentation? Okay, good. Thanks again, WLS team, for having me in this next edition of WLS. And every year, you know, I see the WLS is coming with the new energy, and really thankful to Arijit and other team members to remain fueling their energy, which needs, you know, for driving such kind of forum. And with the very insightful discussion we had on the leadership coming from Jessica and other previous speakers. So now I'll go to from management leadership, I'll go to the technological leadership. And Arijit is laughing because I know you have a soft corner for technology also, apart from the leadership. So, and today world, when the world is kind kind of staging behind the innovation and digital technology, a leadership is going to be incomplete without talking about the innovations which is happening, driving the enterprises and the people and in the entire world. And so one such technology which is driving the large innovation is the quantum computing. And today I'm going to talk why the computing has come as a mainstream. Since quite a few years back, we were talking about AI as one of the innovation area, which is picking up AI, blockchain. We talked about the metaverse. Now, why the computing is coming to center stage? So last year when I was on the WLS forum, I spoke about AI, but this year I wanted to bring your kind attention toward the computing, why this will lead the next set of innovation. Because if you see the metaverse and AI and blockchain, every emerging technology required huge computational power. But can I share my screen here? Okay, just I have a slide to run. I'll just share it. So the challenges in present day computing, we call classical computing, is basically it's 75 years when world saw the first transistors, which have been used in microprocessors and chips, which computes or which works in our data center, which works in our computer and mobile, and every apps and every communication applications and uses these chips. So these chips are, or just say these computing devices are reaching their limitations as Moore's law is no longer going to be relevant. And you might have seen even Intel coming out with their own kind of prediction that Moore's law already got disrupted because they can't package the number of transistors every time, doubling the density, packaging density. So and then a couple of other challenges also, meaning the volume of data, the velocity of data, content, large content, then regulations. So present day computing, of course, is actually reaching the threshold. So if we want to drive the next innovation in AI, which is going to be very computing and resource hungry, if we want to drive next innovation in metaverse, want to drive next innovation in blockchain, then someone has to sort out the computing. So only ray of hope we are having right now is from the quantum computing. So apart from the limitations which these slides talk about, I'll straight away jump into how the quantum computing is actually going to drive or converge with the AI, blockchain, and metaverse. So if you see, as per the one of the recent Deloitte study, it says that the computing for supporting the new innovation in AI and blockchain and metaverse need to be 10,000 times, or maybe sometime 10,000 times, or maybe 1,000,000 times faster than the present computing ecosystem we have. So this is the kind of revolution we need in computing, where just not the data processing power and computing speed to be grown by 10x or 100x, but it's also about analyzing those data, and finding out the insight from data, which are very important. So now here is the emergence of quantum computing. We hear about the traditional computing being done on bits 1 and 0 in quantum computings. The natural positioning of an atom can be a representation of a computer. Like in air, you have atom. At a particular moment, atom can have in one direction of spin, but when you apply some computation, it can change its spin, and which can be measured, which can be an outcome for the computing. So the two major characteristics of quantum computers are superposition and entanglement, due to which they are driving the innovation as far as the speed of computing is concerned and power of computing is concerned. So the computing happens through the qubits. So this is about the introduction of quantum computer. Now even go to the next slide quickly, because we have been restricted with the time. If you see Google, so Google has launched their own TensorFlow quantum computing, and they are also calling it Quantum A.I. So they have especially built up and developed their quantum computing frameworks for AI applications. Similarly, the other vendors are also developing, like IBM. They have also the quantum chips, especially focused for AI and other resource hungry application. So IBM research announced that it found mathematical proof for advantage of quantum machine learning. So they have done a bit research in the quantum machine learning, and where they have speed up the overall classical ML methods. So quantum computing is field of research is still very new. Quantum computers use a lot of quantum mechanics and information. That means they can find pattern in big data, which is impossible to find in the classical computing. I know this is a bit a new concept, but I'll try to explain its application. So artificial intelligence has come a long way in the past few years in able to generate realistic 3D images and videos. In addition, its beginning in quantum computing that has given rise to Quantum AI. So now, what is the Quantum AI? So wherever we are using quantum computing for accelerating the AI application, then that is called Quantum AI. So artificial intelligence now leverages quantum computers, and their full integration will be technological revolution of the century. So there are several benefits of using quantum computing for the AI application. So these benefits are listed here. One of the most extreme prediction of the quantum computing is intelligence in the potential to break through the language barrier. AI models can understand one language, the language used to train them. So if you need AI to understand a different language, we shall need to teach it from the scratch. However, when we use the quantum computing, which can help AI model to break the thorough language barriers. So at the same time, your quantum model, your AI model can be taught in various global languages. So that is the one huge cases we are showing here for Quantum AI. So the quantum chip learns about 63% faster than classical computer, and quantum mechanics makes the system leaner and fewer steps. AI algorithms can optimize the fine-tuned quantum circuits. So quantum and AI will converge in what is called quantum advanced intelligence. This is another trend which is emerging. Their combined power will literally transform everything about life, society, economics, and business. QI will also converge mobility, robotics, Internet of Things, and virtual. Okay, so there are so many huge cases written here. I'll just move ahead. I will come towards the blockchain, quantum blockchain. This is another important area. So like AI, blockchain is also very computing resource hungry. For a cryptocurrency mining, you need to run the mining queries, in thousands and thousands of blockchain nodes. So which requires means a lot of power consumption if classical computing use. So and it takes a lot of time to mine the crypto or you can say Bitcoin information. So there the quantum computing can be utilized. So that is wherever the quantum computing is implied for blockchain application, it is called quantum blockchain. So the combination of computing and blockchain technology come to an quantum blockchain. Like classical blockchain, quantum blockchains are decentralized, encrypted ledger, and how a classical blockchain network could be based on quantum computation. So another thing which we have to know that blockchain is getting, people say blockchain is getting threatened from quantum computer. But I see other way. Of course, you can make your blockchain on classical computing a quantum resistance. But the thing is, you can further encrypt your blockchain applications with the quantum algorithms, so it will become tougher to break the security feature of your blockchain application, for that matter, AI application, or for that matter, metaverse applications. So if you see, quantum computing and blockchains may not necessarily be, that's what we are saying. They are not enemy to each other, rather they are complementing. Some researchers believe that the quantum computing and blockchain technology will end up the merging. This could create more secure, faster, potential, and revolutionary computing solution that could end up helping to solve a variety of both cryptography and real world something. So that's what there is a convergence. Instead of rivalry, there is a conversion between quantum and blockchain technology. So that's this slide in this slide we are highlighting. So major concern is that quantum computers could overpower blockchain encryption. So this concern is already going on. I discussed about that. leading the end of secure cryptocurrency. As we know, the quantum encryption can power. But one of the study of Deloitte showed 25% of Bitcoin could be stolen in one attack. As of January 2020, that world would amount to about $300 billion US dollar, the cryptocurrency. You know, if even 25% of it can be broken, so you can imagine its impact. So now with this, I will come towards a quantum resistance ledger, and then I quickly talk about Quantum Rupee. So we all know that in India, CBDC implementation is going by Reserve Bank of India. So whether it is possible to drive the Quantum Rupee instead of Digital Rupee. So we are talking about Digital Rupee or e-Rupees implementation. Now here are my thoughts. The Digital Rupees pilot launched by Reserve Bank of India, RBI, is certainly going to boost digital economy of India and going to regularize rapidly growing digital payment markets. However, it is also a time for envisioning digital to quantum shift, which is inevitable sooner or later. Hence, India should have a vision for Quantum Rupee beyond presently piloted Digital Rupee. You know, so here are further insights. A closure analysis of RBI concept note on central bank digital currency reveals that quantum tech is just treated as a cybersecurity threat. That's what I was talking. You know, many people believe is a threat to the cybersecurity while rolling out e-rupees, that is Digital Rupees pilot. However, large innovation potential of fast emerging quantum computing technology yet to be explored for Digital Rupee projects. While presenting this year Indian budget in 2022 February, Finance Minister Nirmala Sitharaman talked about introduction of blockchain-based Digital Rupee by the Reserve Bank of India. But in the present RBI concept note on CBDC, DLT, that is distributed ledger technology, being considered as a barrier due to higher computing resources requirements for implementing blockchain-based CBDC. While it appears a true constraint considering the fact that present-day classical computing technology may not support massive blockchain-based Digital Rupees financial transaction, but the power of quantum computing is well suited for conducting billions and billions of financial transactions over widely spread blockchain nodes. So what are the concluding remarks here in as far as the CBDC is concerned? At present, proposed retail CBDC, which is going under pilot, is going to be form of digital tokens, which essentially mean digital form of rupees to be stored in electronic devices based on semiconductor chips, which operates on bits and bytes. However, Quantum Rupee is likely to be implemented by using natural quantum states of the atoms in form of qubits, which shall be more energy efficient as required lesser power to hold its quantum state and contains more information on a qubit. With the power of quantum computers, it is even possible to operate direct mode of CBDC, removing many intermediates of traditional currency supply chain, giving highly productive, cost-effective, and efficient currency supply chain and distribution. 5G research believes that it's time for reimagining currency supply chain and distribution globally, and just not for existing internet and e-commerce ecosystem, but also for the upcoming quantum computing and quantum internet and metaverse-based virtual ecosystem. I think after that, there are some slides here which links the quantum computing we call with the metaverse. We call the quantum metaverse. I'll just walk you through. What I will do. I will upload these slides. And then you can go through it. There is the last slide. It's called Quantum Powered Web 3.0, how the quantum computing will revolutionize the Web 3.0. So with this thought, I coming towards the end of this my presentation, and here my contacts details are given. If you have any query, you can please let me know right now. You can write me in my mail ID also given here, sumant_parimal@inogress.com. Sorry for oversitting my time. Because these are the topics which require some inside discussion. That's what it overstood some time. But I really again like to thank WLS for providing me this opportunity. Thank you, and over to Arijit.
Thank you so much, Sumant. If you could just stop sharing your screen, then we can see your face. That'd be amazing. That's your timer. Please connect with each other, and please share your